In this video, I will be discussing and demonstrating what I refer to as the three magic triangles, which is what I have behind me on the board. I will be providing some background information regarding the importance. I will also share some helpful guidelines, and I will also be demonstrating problems within the triangles. In chemistry, it is important to obtain a capability of being able to discover what you are looking for with a limited amount of information. You may not always be given all the information you want, but you will be given all the information you need to discover what it is that you are seeking to find. It is critical to have an understanding of each individual triangle and the calculations that can be made within them. It is equally essential to properly utilize the three triangles interchangeably because one of their main functions is to serve as the foundation for how you will complete future chemistry problems, such as math with equations, the determination of the limiting reagent, calculating the percent yield, problems within the chemistry lab, as well as many other mathematical chemistry problems. In regards to guidelines, you will need to be able to complete English metric conversions. You will also need to be able to calculate the molar mass and convert between atoms and molecules in order to use these triangles. Your atomic weight sheet that was given to you as a beneficial resource should remain handy during the completion of these problems. If you notice also that moles are present in all three of the triangles, which is what allows for the conversion between all three of them. Also, to reiterate what was stated in the first video, it is important to remain consistent with the unit labels in order to avoid potential confusion and miscalculation. As always, pay attention to significant digits. Also, it is important to identify what you were given and what you are looking for. Here are two of the three magic triangles I've been referring to. In this first one right here, we have grams at the top, moles at the left-hand side, and molar mass on this side, which is equivalent to the grams over moles, grams per mole per se. The second triangle, we have atoms or molecules, and then on the bottom there's moles, and then we have this constant term, which is 6.022 times 10 to the 23rd, and this is the weight that chemists typically assign to one individual mole, which is why it is used as the constant term. In the third triangle, we have moles, liters, and this bolded M is called molarity, which is equivalent to moles over liters. We use these triangles using the process that the bottom two portions of the triangle will be multiplied together to get you the top, or the top portion will be divided by one of the two bottoms to get you the opposite side. The opposite portion of the triangle. In this video, I will begin by completing two problems within the first triangle, then two problems within the second triangle, and then next I will complete two problems using both the first and the second triangle interchangeably. Lastly, I will be completing two problems within the third triangle individually. The purpose of this video is to focus on the breakdown of the triangles and the calculations that can be made within them. With that said, let's begin. I have the problems written right here. I understand that you may not be able to see them as well as I can, which is why I included them on the PowerPoint before the link to this video. So for the first problem, it says, how many moles are in 6.56 times 10 to the negative third grams of sulfuric acid, which is H2SO4. It says how many moles, so we know that is what we were looking for. So moles is present in all three of the triangles. So then we have to use a little more process of elimination. It gives us 6.56 times 10 to the negative third grams. This is a triangle that has both grams and moles, so we now know that we will utilize triangle 1 to solve this problem. So it gave us the grams, so we have 6.56 times 10 to the negative third grams, and we are going to put that over 1. For organizational purposes, we are going to do these similar to the setup of the English metric conversions, and as the problems get more difficult, you will understand why we do this. So we're going to put that over 1. But actually, this one's a little simpler, and it's only a 1-step, so we can actually put that over the molar mass to get us the moles. Now we have to calculate the molar mass. So we have H2SO4. The way I do this is I write each element, and then next to it I also write how many parts of it that we have. Next, you use the atomic weight of each of them, and then you calculate that. So hydrogen is equal to 1.01. And then next we have sulfur, which is 32.07. And then we have the bottom, which is going to be 16. And then when you multiply that together, you get 98.09 grams per mole. We can now put that under our grams here, so we have 98.9, or 98.09. If you notice, we have grams on the top and grams on the bottom. Therefore, those will cancel out, and we will be left with moles. Once you do the calculations for that, you will receive the answer 6.69 times 10 to the negative 5th H2SO4 moles. A few things to point out. You need to have what compound it is that you were describing. Otherwise, you're not going to know moles of what once you get your final answer. Also, you need to have moles because you need to know what it is that you found. And lastly, we had 3 significant digits in our given, so therefore we must have 3 significant digits in our final answer. I will now do a second problem for you. In this second problem, the directions are convert to grams. It gives us 3.579 times 10 to the first moles of carbon dioxide, which is CO2. So, convert to grams. Again, we need to look for grams. We have grams on this triangle, therefore we know we are going to utilize the first triangle. And then we are given 3.579 times 10 to the first moles. And then you see, well, moles is on the bottom, so how do I get to the top? And then you realize you have to multiply it by the molar mass of CO2. So we will need to put that here. As I said earlier, for organizational purposes, we can set these up just how we would set up the English metric conversions. But me personally, I only write what exactly is needed because it prevents future confusion. At least that's the way I feel. So I'm just going to go ahead and put a slash there. So as I was stating before that, we need to calculate the molar mass for CO2. We know that carbon, actually I'm going to do this over here if you don't mind. So we have CO2. As I stated before, write down the elements. Carbon, we have 1 part carbon, 2 parts oxygen. We know that carbon's atomic weight is 12.01 and oxygen's is 16. So once you go ahead and you calculate that out, you should get 44.01 grams per mole. So we are going to go ahead and write that right here. And if you notice, I did not write moles here. So if I were to go back, I might be a little confused as to what I was calculating. This is why I was saying it's important to have that. So we know that this right here is moles. Moles and moles are both present in the equation, so we know those will cancel out, and it will leave us with grams, which is what we were going for. Once you multiply the given moles as well as the molar mass, you should come to an answer of 1.575 times 10 to the third CO2 grams. I have the correct scientific notation in both unit label, well, the unit label and the compound label. Now, I'm going to complete another problem. And then in this problem it says how many moles are in 3.99 times 10 to the negative second molecules of barium chloride, which is BaCl2. It's asking how many moles. So it's either going to be the first or the second triangle, because those are the two that we're using. This will come later. So, and then the next part, it gives us molecules. So, you're going to look, and then we have molecules right here at the top. So we know that that's going to be written at the top of our equation. 3.99 times 10 to the second molecules. And then, as I said, we're going to set these up just like the English metric conversion problems. And then next, you have to think, how do I get from here to moles? Well, you're going to divide by the constant term. We really don't need to write anything there, but that's just personal preference. You may want to. And we're going to write our given right here at the bottom, 6.022 times 10 to the 23rd. Once you multiply this, or once you divide the top by the bottom, you should receive 6.63 times 10 to the negative 26th moles, or BaCl2 moles per se. As you see, I have all the necessary requirements in the answer. I will go ahead and move on to the next problem. This problem says convert to molecules. The second triangle is the one that has molecules within it, so we know that we are going to utilize the second triangle for this problem. Convert to molecules. 56.38 times 10 to the negative fourth moles of methane, which is CH4. So, we know that molecules is at the top, so we will have to multiply the given moles by the constant term. So the moles that were given is 56.38 times 10 to the negative fourth. You can go ahead and put that over 1. And as I previously stated, we will be multiplying that by the given. And then once you multiply that out, you should receive 3.395 times 10 to the 21st CH4 molecules. As I have been stating before, correct significant digits, correct compound, and correct unit label. These next two problems are going to utilize both the first and the second, both the first and the second problems, or the first and the second triangles together. I apologize for that. This problem says, how many grams are in 2.243 atoms of hexane, which is C6H14? How many grams? So we know that we will be using both the first as well as the second triangle. So, and then go ahead and read it. We have 2.243 atoms, which was our given. So we are going to write that at the top. Make sure that you have your label. Go ahead and put that over 1. Next, so we have the atoms, and then we're going to divide by the constant to give us the moles, because once we have moles, we have free range to move throughout the other triangles. So dividing that by the constant, which is 6.022 times 10 to the 23rd, will give us the moles. But we are asked for the grams, so we're going to have to multiply the moles by the molar mass to reach the grams. So therefore, we need to calculate the molar mass of hexane. Go ahead and do that right here. So we write the elements, carbon and hydrogen. You know, we have 6 parts of carbon and 14 hydrogen. Then we're going to multiply that by their atomic weight. And then once you multiply that out, you should get 86.02 grams per mole. So we need to add that to our equation up here. As I said before, we will have to multiply it, therefore that will be placed on the top. Be sure to include your unit label. So we're going to multiply atoms by the moles divided by the constant. It's important not to break it up because the significant digits, if you break up the equation, there will be points in which you round off. Therefore, your final answer will not be as exact as it technically should be. As I was saying, when you multiply this out, you will get an answer of 3.21 times 10 to the 22nd C6H14 grams. My answer has all the necessary components, so I will go ahead and move on to the next problem for you. The next problem asks, how many molecules are in 3.97 times 10 to the 5th grams of vanadium bromide, which is VBr2. It's asking for molecules. So we need to end up here, but it's giving us grams. Therefore, we know we're going to start with the first triangle. We are going to write our given on the top, which is 3.97 times 10 to the 5th grams we'll go ahead and put that over 1. So we have grams, and as I previously stated, we need to get to moles so that we will be able to transfer to the second triangle. In order to do so, we will need to divide by the molar mass. We have vanadium bromide. So we have vanadium and bromide, 1 part vanadium, and then 2 parts bromide. The atomic weight of vanadium is 50.94. and the atomic weight of bromide is 79.90. Once you multiply that out, you should get 210.74 grams per mole. We are going to need to place this right here so that it can be divided. And we can put a slash up here because we don't really need the information. So, taking the grams, dividing by their molar mass, will give us moles, and now we can move to this triangle. But we're asked for molecules. So we're going to have to multiply this by the constant term, which is 6.022 times 10 to the 23rd. And then once you multiply that out, you should get 1.13 times 10 to the 27th vanadium bromide molecules. And that will be your final answer. It has all of the necessary parts, so we are finished with that one. And that concludes the problems that I'm going to be completing within the first and the second triangle. This is the third triangle, the third magic triangle I've been referring to. And then we have the moles, liters, and molarity. We use this triangle using the same process as the first two triangles. So I will now demonstrate two problems within the third triangle individually. Need to put up my problems. Again, I know that you probably cannot read these. This is why I included them on the PowerPoint for you. The first problem says sodium was added to water to speed up the boiling process during cooking. How many moles of sodium were added to the 3-liter solution of water if it had a molarity of 5.367? Your first step is to go and read the problem and discover what you were looking for. This says how many moles. So we know that we are looking for moles, and then that leaves our option to multiply the given liters by the given molarity. So in this problem, we're going to multiply 3 liters by the given molarity, which was 5.367. And then once you multiply that out, you should get 1.610 times 10 to the first sodium moles. We have our liters multiplied by the molarity, and then we are given our answer. It's moles per liters for the molarity, you just can't see that written. Then I'm going to do the final problem. If there are 5.327 times 10 to the 8th moles of NaOH in a 25-liter solution, what is the molarity? So we know we're looking for molarity, and we were given both moles and liters. Therefore, we know we're going to divide the moles by the liters, and that'll give us our answer. So we are going to take 5.327 times 10 to the 8th moles and put that over 1. And divide it by our liters, which was 25 liters. Once this is divided by this, you should end up with the answer 2.131 times 10 to the 7th molarity of NaOH. And the bold M represents the molarity. That concludes all the problems that I will be completing in this video. I want to thank you for watching the video. I hope it helped you achieve a better understanding of the three magic triangles, and I can guarantee that they will remain important throughout the rest of your chemistry course.